Problem 819 has to do with commuting time to work. It would actually be interesting to see what's happened with this during the pandemic, because fewer people are commuting to work, which some people are loving the fact that they can work from home. And a lot of people I talk to would say, I wish I could do this all the time. And of course, because there's fewer people commuting to work, there are fewer cars on the road, less use of public transit, and things along that line. So you can probably get to work even faster because fewer people are actually driving to work. So in 819 on page 257, we do a sample of 30 cities. We find out that the average time to commute is 138.83 repeating. These are in minutes. The standard deviation is 17.51. We want to determine the 95% confidence interval. So in this particular case, once again, this is a sample for determining and trying to estimate a population. It'd be very difficult, basically logistically impossible to find out what the population mean would be. So we take a sample of 30. We see that the two numbers calculated at 95% are anywhere from a low of 132.29, which is the lower bound of our confidence interval, to an upper bound or limit of 145.37 minutes. So what does this mean? This means that we are 95% sure that the population mean is between 132.29 minutes, 145.37. And as I've been stressing, there's a 2.5% chance it's below 132.29, and there's a 2.5% chance it's above 145.37. Now, we make an assumption in part C that the population is normally distributed. And the larger you get a sample size, it is considered to be better, that it would become more like like a normal distribution. And that's called the central limit theorem, which we took before. And as long as the distribution is not, as they call it, seriously violated, and what they would mean by that, it's skewed or asymmetric. As long as it's close to being normal, a sample size of usually 30 is fine. And there were some limitations in the past before we started using Excel, where you would have a t-score, a t-value, and all that could fit on one page would be 30. So that was kind of considered the upper limit, but we don't have that limit with Excel. We can have, we can get t-values of 129 if we want, because Excel will look that up in the t distribution. So in this particular case, it's fairly straightforward. We're 95% sure it's basically 132 to 145 minutes is what the average commute is. So if you're a planner for, say, the city of Calgary, you'd want to pay attention to this and find out how long is it taking people, and you would break it down by, say, quadrants of the city. The other thing that you would do, not exactly related to this, but when I worked in the healthcare sector, one of the things you would pay attention to was, where do you place an ambulance station? And where do you even place a hospital? And they would set certain standards of time for how long it should take for an ambulance to get to where you are. So that travel time is important for how long, in this case, driving to work. So if you're a few minutes longer, not such a big deal. But in the case of healthcare, it can be actually a big deal, where somebody has had a heart attack, and every minute that goes by reduces the probability that those people will survive.